Hi, welcome to my Foundations of Computing presentation. My name is Stephen Walsh and my student number is 2001-8950. The first part of the presentation concerns the CPU. The term CPU stands for Central Processing Unit. The CPU is divided into 5 components: buses, RAM, the control unit, registers, and the ALU. There are 3 types of bus: the address bus, the control bus, and the data bus. The address bus interacts with I/O and memory only. Data buses carry data only, and the control bus sends read or write signals to indicate if the CPU is sending or requesting information. RAM stands for Random Access Memory and is composed of several complex integrated circuits. It allows data to be stored and accessed in any random order, and RAM is volatile. The control unit is often referred to as the brain within the brain of the computer. The control unit is the component which directs the flow of information within the CPU. It is composed of the decoder and the multiplexer, and performs the tasks of fetching, decoding, managing, execution, and storage of results. Registers are a type of memory unit which can be accessed very quickly. For example, data registers hold numeric values such as floating point numbers or integers. Address registers hold addresses which can be accessed quickly. The ALU stands for the Arithmetic and Logic Unit. It executes all the calculations for the CPU and has the ability to add, subtract, multiply, and divide binary numbers.
Von Neumann architecture versus North and South Bridge chipsets. In von Neumann architecture, the CPU consists of 5 parts: the ALU, the control unit, memory, input-output, and a bus for data communications. On a more modern motherboard, North and South chips are present. The CPU is connected directly to the North chip, as this chip is responsible for faster data communications. The South chip is connected to the North Bridge chip, and the North Bridge chip is connected to the CPU. Therefore, the South Bridge chip is not directly connected to the CPU and is given the responsibility of slower data communication. The fetch and execute cycle. A fetch and execute cycle is the basic operation cycle undertaken by a computer. The computer retrieves a program instruction from its memory. It then determines what the program instruction requires and carries out the necessary steps to execute this instruction. This is an example of the fetch and execute cycle. As we continue the program counter, it's set to 76. Operation 76 in RAM says load 70 into the AC. The instruction of 76, which says to load 70 into the accumulator, is put into the instruction register. Then 70 is put into the accumulator, or the AC. The program counter is set to 77. Operation 77 says to add 71 into the accumulator. This is put into the instruction register. 3 is added into the accumulator, which gives us 2 plus 3, which is equal to 5. The program counter is set to 78. Operation 78 says to store the results to 72. The result, which is 5, is added into the memory slot of 72 on RAM.